first example. And we are solving. So the first one has 3a minus 6 equals a plus 4. So if we look here, we could put a line through here. I have variables on both sides. So you need to decide where to keep your variable. My recommendation is always move the variable, move the letters to the left side. So if that's the case, I'm going to subtract a. Now remember, that's a 1a. So this is 3a minus 1a minus 6 equals to 4. Now this 3 minus 1a becomes 2a minus 6 equals to 4. This line through the equal sign continues to happen. Now I'm solving for a, so I need to move that 6 over. So I do that by adding 6. These cancels. This becomes 2a equals 4 plus 6, which is 10. If you could add here, and you don't have to write it out by now, because we've already done a couple of problems, you could just go ahead and do that. Divide by 2, so a is 5. That's a horrible looking 5, but it's 5. Now remember, you could check your work all the time. I'm not going to check all of them, but I'm going to go ahead and check this one. 3 times 5 minus 6 equals 5 plus 4. Well, what is 3 times 5? 15 minus 6. What is 15 minus 6? 9. What is 5 plus 4? 9. So does it become the same? It sure does. Next problem, 17 minus 7x plus 3 equals negative 3x plus 21 minus 3x. So what I'm going to do here first is rearrange things, group things that would have to go together. Negative 7x plus 17 plus 3, negative 3x, negative 3x plus 21. So I kept everything on the same side, but I'm going to group these two, and I'm going to group these two. Now, this is negative 7x. 17 plus 3, they're both positives. It becomes 20. Negative 3x and negative 3x. So it becomes negative 3, negative 3. They're both negatives, so it becomes a negative 6x. Negative 6x plus 21 with an equal sign. So now it looks, so I combine whatever I could on both sides, and now I should be able to work and do what we did in the first one. I have an x here and an x here. Like I mentioned, my recommendation is to move your variable all the time to the left side. So I will add 6x, add 6x. This just becomes 21 on this side. This plus 20 is still here. I have a negative 7x plus 6x. So this is negative 7 plus 6, and negative 7 plus 6 is a negative 1x plus 20 equals to 21. We still have a line going through that equal sign. My x's are on one side of the equal sign, which is perfect. So now I have to subtract 20 to leave that x alone. So I have negative 1x equals 21 minus 20, and that 21 minus 20 is just 1. But we need to solve for a positive x, so I have to divide by a negative 1. So when I do that, x equals negative 1 divided by 1 divided by a negative 1, which is a negative 1. And that would be your answer for that problem. You could plug it in to check. Problem C. 7 parentheses x minus 2 equals 9x minus 6. So in this one, the first thing we have to do is distribute on both sides. 7 times x minus 7 times 2. 7 times x is 7x. 7 times 2, negative 14, equals 9x minus 6. Once again, I have an x on both sides. So move those, whoever has an x, to the right side, to the left side. So this is the one that has an x. If it's a positive 9x, I have to subtract 9x. So this becomes 7x minus 9x minus 14 equals negative 6. Now keep in mind, because this one had this minus 6, this is why it's a negative 6. So 7 minus 9. If you have to rewrite it like this, but if you know, hey, I have to subtract those. What's 9 minus 7? It's 2, but because the 9 is bigger, it's a negative 2x. Minus 14 equals negative 6. I have to add 14, add 14. So I have negative 2x equals negative 6 plus 14. I see one negative, one positive number, so that means I have to subtract. 14 minus 6 is 8. 14 is bigger, so it's positive, so it stays positive. We divide by a negative 2, and I get x is a negative 4. And you could check your work, and you'll see that you have the same answer. So we're just incorporating all the different sections, all the different properties that we have practiced in all the other problems. Let's do one more. Okay. 3 parentheses 2x minus 6 plus 6 equals to 0. So, okay, we have to distribute. 3 times 2x minus 3 times 6 plus 6 equals to 0. So you only distribute that 3 to what's in the parentheses. 3 times 2x is 6x. 3 times 6 is 18 plus 6 is equal to 0. Now that 18 is negative. And this is a positive. So we obviously have to subtract, which is 12, but it will be a negative because the 18 is negative. So we have 6x minus 12 equals to 0. We have a line going through that. Yes, we have a variable here, so that means we have to move that 12 over. So we add 12, and I get 6x equals to 12. Because 0 plus 12 is just 12. We divide by 6, x is a positive 2. So my answer would be a positive 2, and we're done. Now, we have been, at the very end of 3.2, what we did was translation of words into problems. So the only thing that we're going to do here is introduce the words that would mean equal. They could say words that mean equal. And in the other section, we covered the words for addition, subtraction, quotient, and product. So the words that mean equal would be words for it to say equals, gives, yields, is, was, amounts to, is equal to. So all these words mean equal. So looking at example number 2, translate each sentence into an equation. So that's what we're going to do for example number 2. So the first one, it says the product of 7 and 6 is, and I am writing the word equals to, is, that's horrible, sorry, is 42. So what does that mean? Product 7 times 6 is means equal 42. So this would mean equal. Twice the sum of 3 and 5 is equal to 16. So twice the sum. Well, first let's take care of the sum. Sum means 3 plus 5. Is equal to means equals to. Twice means we multiply this times 2. Twice the sum of 3 plus 2, which is 8. 8 times 2 is 16, so that's very true. The quotient of negative 45 and 5 yields negative 9. So what does that mean? Quotient means we're dividing. Negative 45 by 5. Yields mean equals to 9. And there it is. So we're just doing translation. Now, this is it for 3.3. If you have any questions, please let me know. So we're going to be using all the words for addition, subtraction, multiplication, division. We're going to go ahead and add the words for equals. The equal sign, which was equals, gives, is or was, yields, amounts to, or is equal to. So for the first example, we're gonna write the algebraic equation. And the algebraic equation, yep, that's it. So we're going to continue to do what we were doing in the previous one. So for the first one, let's say that I have 20 increased by a number is 5. So first of all, 20 increased by, so we have 20, it's increased by, so that means addition by a number. We don't know the number, so we're going to put x equals to 5. That's it. Twice a number equals twice a number equals negative 10. So what is different from this and the last ones that we did in 3.3 is that here you have an unknown. You have an x. So for this one, twice a number, 2 times a number, well, let's just say it's x, is negative 10. So 2x equals negative 10. A number minus 11 amounts to 168. So here we have a number, so that's going to be x. We're going to minus 11, and it's going to equal to 168 because amounts to means 168. Oops. 3 times the sum of a number and 5 is negative 30. So what does this mean? 3 times the sum. So let's do this part first. The sum of a number and 5. 3 times that sum is negative 30. Next one. The quotient of twice a number and 8 is equal to 2. So for this one, we know quotient means division. So we're going to have division. Twice a number, so that's 2x. And 8 is 2. So these here are translations of algebraic expressions into equations. Now, when you're solving problems, there are steps to solve these problems. The first thing that you need to do, so let's look at problem solving. Problem solving. And sorry for that rotation again. Problem solving steps. So let me move this up. Let me make it a little bit bigger. And then start the numbers. We need to understand. That's the first thing. We need to understand the problem during this step. We need to become comfortable with the problem in some ways of doing so. And how can you understand? You could either read, you could construct a drawing, you could propose a solution and check. Propose a solution and check. Pay careful attention to how you check the proposed solution. You could choose a variable to represent an unknown, the way we have been doing in these algebraic and the problems that we just did right before. Now, the second thing you have to do is translate. Translate the problem into an equation. The next thing you do would be to solve the equation. And the fourth thing you would do would be to interpret the results. Which means, basically what it means is you could check. Or if they're talking about gas, make sure you know what you're talking about and things like that. So let's look at the following problem. And the problem says twice a number. So let me see if we are in example number 2. Make this a little bit bigger. And sometimes the problem is just something simple. We need to find the unknown. So the problem they give us here is twice a number plus 3 is the same as the number minus 6. Find the unknown number. So the first thing we need to do is understand the problem. To do so, we need to read once, sometimes read twice. So let's propose a solution, and suppose the unknown number is a 5. So this is us just guessing, so we're trying to go by doing this one. So we're going to guess the answer is 5. So if we're saying it's 5, we're proposing. Doesn't mean that this is correct. That means that twice a number, twice 5, plus 3 is the same thing as that 5 minus 6. Twice the number plus 3 is the same thing as that number minus 6. And if you're saying it's 5, we could check here. Is this going to be 10 plus 3? Is it the same thing as 1? No, it's not. So us proposing that it's 5 is not the right answer. But we could do number 2. Translate, which I already did here. So using the second option over here, we translate, and I have twice a number, 2x, plus 3 is the same as, so that means it's equal to that number minus 6. So now when I look at this, I could do step number 3, which means solve, and we've already done that. So we have an x here and an x there. They need to be on the same side, so I'm going to subtract this 1x. 2 minus 1x is just x, plus 3 equals negative 6. Minus, I have to subtract 3 to make sure we leave the x by itself, and I get a negative 6 minus 3, which means a negative 9. Now remember, in order to interpret, you could check your results. So you could see, is 2 times a negative 9 plus 3 the same thing as putting a negative 9 minus 6? Well, this is negative 18 plus 3, which is negative 15. Negative 9, negative 6 are both negative, so that becomes negative 15. So we have checked, we have interpret, and that is correct. So basically, that's what you're going to be doing, or you could be taking situations. So let's try. I'm sorry for all this flipping. Let's try another example. I'm not going to write the entire problem, but we have, and hopefully you can hear me well, a salesperson at electronics store sold a computer system and software for 21. So we have a computer with software, and they sold it for $2,100. Okay? Receiving 4 times as much money for the computer system as for the software. So we're receiving 4 times, receiving 4, and let me write it out in words. 4 times as much money for the computer system as for the software. Find the price of each. Find the price of each. Well, first we need to understand the problem. We read and reread the problem, and we could say that the one that we know least about is the software. So we're going to let X be the software. If X is the software, then that means that 4X would have to be the computer system because of what it mentions in this receiving 4 times for the system as the software. So the software has to be 4X. So then we could do the translation, which means that 4X plus Y together, the computer system and the software, it sold for $2,100. So I could combine these because now I'm going to do into step 3, which means I solve because these both have an X. That means I could add them together. 4 plus 1, 5X equals 2,100. I'm going to divide by 5, divide by 5. X equals 2,100 divided by 5, which is 420. So this 420 means that since your X is the software, that software is 420. But because I have the computer system that is 4X, I have to do 420 times 4. That's 0, that's 8, that's 16. So my computer system is 1680. So that's where we would take word problems and translate it into math problems. If you have any questions, keep your notes with you while you're doing your assignment.